Hi there. Today we're going to talk about inequalities in triangles, and we're going to start off with just looking within one triangle, that's in 5-6, and then we'll look at if we have two triangles and the inequalities that are involved with those, that's 5-7. And we're going to start with this concept we have on, this is Theorem 510, and this is kind of a major concept that follows into other classes and other shapes other than just triangles, but it looks like what we have here. It says if two sides of a triangle are not congruent, then the larger angle lies opposite the longer side. In other words, right here, the only way that this leg here can be longer is if this angle opens up wider to create that long side. So if this is longer, the angle is going to be bigger than what's going on over here. Shorter side, you're going to have a smaller angle. So I kind of just abbreviated, the larger angle is always across from the larger side. So let's look at how we might use that. So if I'm looking at this triangle here, I have two angles given to me, and I'm supposed to put these in order from least to from shortest to longest, the sides. Okay, and it's multiple choice. They're giving me options here. Well, if I look at the angles, this one's 62. That's bigger than 58, so I know that the TU has to be longer than the TV. But what about this UV? They were kind of sneaky on me a little bit. They're expecting you to know that what this angle up here would have to be, because we have to incorporate this third side also. So if you look at this, what would we end up with there? That'd be 120 for these two added up, which means you've got 60 degrees left over for that one, because they add up to 180. So if this is 60 degrees up here, now I'm going to put these in order least to greatest. So the 58 is the smallest. So across from the 58 is TV. So I know when I'm looking at my options, this is not going to be correct, and this is not going to be correct. It's going to be D or A, because they both start with TV as the shortest. The next shortest would be across from the 60. That'd be UV. So that tells me my answer is going to have to be A up here. Okay, let's look at this next one. In the figure at the right, if this angle S is 24 degrees, okay, and angle O is 130, and again, I can figure out what this missing side would be. I need to know that before I can really designate which side is going to be the shortest side. So if you look at, this is 130, so 50, that's going to have to be a 26 degrees for that to all add up to 180. Which then means, oh, the 24 was the the smallest, so the side across from that has to be the shortest side. I would say segment OX is the shortest side. All right, so let's look at this one. It says determine which segment is the shortest in each diagram. Now this gets a little trickier because you can see that there's multiple triangles going on here. So let's start with this first one. I've got a 30-degree angle over here, but notice that this is isosceles. And so if these two legs are the same, their base angles are also the same. Now I'm going to look at this, and if that's 30, that leaves me 150 to divide evenly between these two. That means they would each be 75s. So I'm going to look at, that's a 75, and that's a 75. Now you have to be careful when you start trying to connect it over to the next triangle, because that's not necessarily, that's a different triangle. So just because you have a 40, or in this case, doesn't necessarily make this side opposite bigger because you're in a different sized triangle. So I'm going to still do the same. Actually, here's what I tend to do with these. I'm going to start off with this PQR triangle that I've dealt with, and I know that this is going to be the shortest side for this triangle. Now that's the shortest side, okay? But is it the shortest when you start looking at the next triangle? Well, I've got a 90, I've got a 40, that leaves me with a 50 for this one. So when I look at this triangle on the right side here, even though this was the shortest leg over here from this triangle, this is not going to be the shortest leg when I look at this triangle. When I look at this triangle, the RS is across from the 40. This is even shorter than what this one is. So I'm going to have to say that RS is the shortest in the overall picture. RS would be the smallest size. Okay, let's try that again. All right, I'm going to start over with one of these triangles. Let's do the one that's on the left again. I got a 110. I've got a 32. Subtract that from 180, and you'd have, what is that, 38? All right, now, when I look at this particular triangle then, I would say that the 32 is the smallest, so this would be the smallest leg in this triangle. But does that carry over? This one right here would be a little bit longer because of the 38. This right here would be a little bit longer than that one, which makes me wonder then if this is a little bit longer, what's good? I mean, and I know that this one is shorter. Right now I'd say that one's the shortest. Let's come over here to this triangle on the right. I've got a 30 and a 114. Subtract that stuff from 180 and you'd have 36 for this angle right here. Okay, now if I look at this triangle then, I would say this is the smallest side right here. This one's the smallest, it's across from the 30. But I've already designated this side up here as being even shorter than that side. So that means this CD must be the shortest in the overall picture. Kind of have to work your way from one to the other. All right, here we have the triangle inequality theorem. This is kind of a biggie. This is one we talk about a lot in geometry and future classes as well. When you try to create this triangle, not any three side lengths will create a triangle. And we did this way back at the beginning when we were doing constructions, and I'd give you these three side lengths and you had to make a triangle. Well, sometimes it didn't work. Let's talk about when it would work and when it would not. This first example, this is a nice triangle. You have one leg that's 5. These other two are 3. They're conveniently the same length, but they wouldn't have to be. It just creates this nice triangle. But if you look at this triangle over here, and this would be the tricky scenario. If I make one of these legs really, really long, let's say 6 centimeters, if my other two sides, let's say we're going to be 2 centimeters long, well, the problem that I have is these are not long enough to actually reach each other. Even if I shrunk this down and made those angles smaller, 2 centimeters would only land right there-ish. And over here, it'd only land right here-ish. Those would never, ever touch. They could not create a triangle. All right, so when does it work? When does it not? Here's what it says. The sum of the lengths of any two sides of a triangle is greater than the length of the third side. The sum of two sides, so this 3 and 3 adds up to 6, has to be bigger than the third side. Yep, 6 would add up to be bigger than 5. And over here, if you add these two up, you can see that adds up to 4. That's not as big as 6, so it's not going to create a triangle. All right, so let's just practice that. With this next one, would this make a triangle? So what we typically do, for it to make a triangle, you got to grab your two smallest ones. So that's going to be my 2 and 6. And they add up to 8. And since 8 is smaller than 9, they will never reach, they'll never touch. So I would have to say no, that one does not create a triangle. Over here, again, pick the two smallest ones, that's the 4 and 6 in this case. Add them up, that gets you 10. Now 10 is bigger than 9, and so they would be able to reach each other, so that would be an example of one that did work, that would create a triangle. All right, so let's take it to the next level. If two legs of a triangle are 5 and 8, what are the possible lengths for the third side such that it would still be able to create a triangle? So I'm pretending right now that this one here is 5 centimeters and this one is 8 centimeters. Now, if I have some measurement that would fall in between here, like if this was really, it could only be 6 centimeters or 7 centimeters, that's always going to work, because this whatever I would pick for this other side, this 6 centimeters or whatever, that's going to easily add up to be as big as that. Or if it was 7 centimeters, would add up to a 12. That's easily bigger than the 8. What I really have to work on is, what if I had a really short leg over here? Like, what if it was only 1 centimeter long? Would that work if I have a 1, a 5, and an 8? Nope, it wouldn't, because 1 and 5 would only add up to 6, and that wouldn't be long enough. How about a 2? Would 2 work? 2 and 5 would be 7. That would not work. How about a 3? Well, that would be 8. The problem with them being exactly that value is they wouldn't actually touch until they were flat along the base. And so it can't be 3, but it could be anything bigger than 3. It could be 3.1 or 3.2 or 4 or something like that. But my cutoff would have to be 3. So I would say that it could be anywhere from a 3. And then you come up here, what if this leg, and okay, so that's one of my options. That's the low end. It's got to be bigger than 3. Bigger than 3. Okay. And then over here, I'm going to write that down here. It's got to be bigger than 3. Over here, instead of the 3 now, let's say the 5 was the shortest, then the 8, and then maybe we had this super long one over on this side, bigger than 8. Well, how big is too big such that these two won't create a triangle out of it? Well, if you think about it, the 5 and the 8 together add up to 13. So this needs to be longer than 13 to create any trouble. So if I can keep it shorter than 13, I'm going to be okay. So I'm going to say 13 is my upper end. It has to be smaller than that. And usually the way we'll write this is we'll say x, which represents the third leg, has to fall somewhere between 3 and 13. But it can't actually equal them. It has to be bigger or less than. So here's how we set this up. It's a nice compound inequality. X has to be bigger than the 3, but it has to stay smaller than 13. And then it would create a triangle. And if you look at where this came from, so I kind of walked you through it, but ultimately what we were doing to get the low end, we just subtracted those two numbers. To get the high end, we just add the 2. And we just set it up like this. Don't do an or equal to, because an equal to would not work. It has to be fall in between those values. All right, so let's come up with a little formula then that you can use. If I give you two side lengths, A and B, and the third side length is C, then I would write it like this. C has to fall between, down here I would take B minus A, and up here I would take A plus B. In the order that you add or subtract, well, you're going to take the big one minus the small one. But this is kind of your formula. To find the low end, subtract. To find the high end, add. So here we go. A triangle has side lengths of 4 and 7. What's the range of possible values? If I subtract them, I get 3. If I add them, I get 11. And it works like that. Pretty easy once you get the hang of it. All right, so now we're going to move on, and we're going to look at inequalities if you have two triangles. Now, this has a special name. They call it the hinge theorem because you kind of think of it like it's a hinge and how far it opens. But it's called Sideangleside Inequality. What that means is you're going to know two sets of sides are congruent. If you see your picture here, I have this side and this side congruent. And then I have this side and this side congruent. But that included angle right there, which is my angle A or my angle X, that's my included angle. They're not the same. We're not proving the triangle's congruent. It's not that side angle side. It's a side angle side inequality. The angles are going to be different. This angle is bigger than what this angle is. Well, think about this. If it's a hinge and it opens up wider, what's going to happen to that leg as that hinge gets wider? Well, that leg's going to get bigger. And so that's what this is saying, is if your hinge, if your angle is bigger in one triangle than it is in the other triangle, then this leg is going to end up being longer than the leg from across from the small one. Now this works in two triangles, but you have to have the two sides congruent before you can do the hinge thing. Okay, so let's look at this one here. You can see I've got a single hash mark and a double, same thing over here. And the included angles are different. This angle is 90, whereas this included angle is 70. So that hinge over here is opening up wider, so this SK is going to have to be bigger than this hinge creating UY. So when I do multiple choice, I'm trying to figure out SK, we just said has to be bigger than YU. SK, nope. Right there it is. SK is bigger than YU. We'd circle B on that. Oops. All right, Let's try again. It says, what inequality relates LN and OQ? All right, here we go. I've got a 4, so that's a single hash mark, single hash mark. Got a 7, double hash mark, double hash mark. So there's my sides, and my included angle, you can see here, is a 78, whereas over here it's a 125. Since this hinge is opening wider, then LN is going to have to be longer than what happens over here with OQ. So to compare them, I would say LN is greater than OQ. Now this works the other way also. Instead of doing a side angle side scenario, if you have the two sides congruent and you know the relationship on that third side, it's going to relate back to the angle, that included angle. So look right here. You got your A and your B, or your two sides. You have your two sides congruent, two sides congruent. And we also know that this leg, you can see right here, this leg is longer than what this leg over here is. Well, if this leg is longer, then this hinge is going to have to open up further, which is going to make angle A bigger than this angle X here. If you know the relationship of the third side, then you can make a statement about that included angle. All right, let's look at this problem and kind of use that converse of the hinge theorem. It says, what is the range of possible values for X? X is right here. Okay, got it. So now I see my two triangles. I see that I have a single hash mark on each. Plus, don't they share this side right here? So that would be the same, little reflexive business going on there. These two legs would be the same. By doing that, I have these two side congruences, and I know the relationship on the third side. The third side over here is 10, whereas the third side on this one is 15. And the only way that this can be smaller than this one is if its angle, its included angle, its hinge, if that hinge there is smaller than the hinge over here. All right, so this right here, 5x minus 20, needs to be smaller than 60. But we have to be careful. That's the major part of this problem. But we do want to be careful that this does not get so small that it doesn't even work in the triangle. So if you think about this, this has to create an angle that's at least, what, 1 degree? We have to have something there, right? So we're going to let this fall somewhere between 0 and 60. That's what it would have to be. So that's how we write it. We come up here and we say, all right, it's going to fall between 0 and 60. And anytime you're doing like an interval, we do it like we did on that last one. It's a 5x minus 20. And that has to be bigger than the 0, but it has to be smaller than 60. Okay, this kind of takes you back to Algebra 1 when you solve this compound inequality. I know to isolate my x, I kind of treat it like two different problems, but I'm going to solve them at the same time. Do you remember doing that in Algebra 1? I'm going to add 20, but I'm going to kind of work with it like it's a problem here, and I'm going to ignore this. But at the same time, I'm going to work the problem like it's this one, and this isn't there. I'm going to add 20, but I have to add it there, and I have to add it there, because I'm going to add it, I'm going to solve these problems simultaneously. All right, what that means is 20 is less than 5x, which is less than 80. Divide by 5. And again, I would have divided this by 5, but if I was solving on this side, I would have divided that by 5. And in the end, I end up with 4 less than x less than 16. And that's the range of values that x could be. X has to fall somewhere between 4 and 16. All right. How about if you tried this one on your own? It's kind of just like we got done doing, same idea. See if you can do this one. Go ahead and take a minute to pause the video. You work through it. When you're done, come back to the video. All right, here's what I got. I said that this angle over here, since it's across from a 7 versus this one being across from a 9, this one has to be smaller than what this is. It has to be smaller than 90. That's what I set up. But I still want to make sure that the angle itself is at least a positive measurement, so I said it was greater than 0. Now, in the process of solving this, I do end up with an x value that could possibly be negative. And that's okay if x was negative, as long as it didn't get too crazy negative, that it wasn't going to work. So that's what I'd go with. All right, so that's kind of all we have on the inequalities. Hopefully this helps. Good luck.